Now let's solve the algebra. The, the case with flat road is easier, so let's do that first. We have a normal force that can be equalized with the mass times the gravity. So let's just replace the the normal force here with n times g. This is just this part of the equation, which I replace n with mg. Now there's mass on both sides, so I get that for a flat road, the square of velocity is smaller than rg times mu s. Now for the case with curved road, there's n, fs, and n. I'm going to use this inequality that limits the value of fs, so I want to isolate fs. Let's move this part to the other side, and this gives me m v bar squared divided by r minus m bar sine 30 will equals to fs cosine 30. And this thing should be smaller or equal to mu s n times cosine 30 because the fs here is smaller than this value. I can do the similar thing to the other equation. Now I'm going to put mg and m bar cosine to the other side. So that isolates fs sine 30, which in this case will be smaller than mu s n bar sine 30 degree. Then I will have fs. So I had already used this equation here, so I don't need to write them again. So you see now I reduce the equation from 3 into 2. I can first solve for this combined equation. I will skip the intermediate step to make the thing look nicer. This part is not needed anymore. So let me remove it. This equation is smaller than this, and this one is smaller than this. Let me move the n together, and v bar squared r smaller than n times a complicated coefficient, which is mu s cosine plus sine. And the same thing for the other equation. Mg is smaller than n times a complicated coefficient, mu s sine plus cosine. Now, what I'm going to do is simply divide the left-hand side, or actually I'm going to replace n here with mg divided by this. So mv bar squared r is smaller or equal to mg times a complicated factor, this in the numerator and this in the denominator. Good. So we have m on both sides, and now I get that for tilted road, the velocity is limited by rg again, but with a complicated factor. So we can try to get the ratio between v bar and v, which is the case with no inclination. It will be a square root because I have square over here. And in this case, I have rg with a bunch of stuff, and rg is in the numerator. I'm going to divide it with v squared, and v squared will have rg mu s. So this is the ratio between the velocity square or the maximum velocity square. This is maximum, and now we have a square root because I want to get just the ratio between the maximum speeds. I can delete r and g now and plug in the numbers. I will have the mu s cancel each other first because alright, that's actually not easier, so let's just write mu s, and cosine is going to be square root of 3 divided by 2 plus 1/2, which is sine 30. And now I have the mu s times mu s square root of 30 degree, and I mean sine of 30 degree, and square root of 3 divided by 2. So this is my ratio. I can then use my calculator to calculate it. On the top, it will be 0.18 times square root of 3 divided by 2 plus 0.5. So it's 0.656. 0.656 in the numerator, and in the denominator, it will be 0.18 times a parenthesis of 0.18 times 0.5 plus square root of 3 divided by 2, and this gives me a 0.170, 0.172. So let me divide 0.656 with 0.172 and take a square root. I get about a factor of 2. So with an inclination, we can simply increase the maximum velocity by a factor of 2, which is pretty good.